Welcome, friend. If you're settling in for the night, finding that perfect position where your pillow cradles your head just right, then you're exactly where you need to be. Tonight, we're going to explore one of the universe's deepest mysteries. Together, something so familiar, yet so strange, that scientists still argue about its very nature. We're going to ask a question that sounds simple, but opens doors to infinity. What is time, really? No equations tonight. No complicated theories that make your brain work harder than it should before sleep. Just wonder, just discovery, just you and me, wandering through the most beautiful puzzle the cosmos has ever presented. And if you enjoy these journeys into the peaceful unknown, a gentle like or subscribe helps other seekers find their way here too. So take a deep breath, let your shoulders drop, let the day release its grip on you. Let's begin. Time doesn't flow like a river, despite every metaphor you've ever heard. Right now, as you listen to these words, you might imagine time as something moving past you, carrying moments from future to present to past, like leaves on a stream. But Einstein discovered something that changed everything. Time doesn't flow at all. It simply exists, stretched out like a landscape, and we move through it. The flow of time is an illusion created by consciousness itself, by the particular way your brain processes reality. Think about that for a moment. Every second you've ever experienced exists somewhere in the universe's structure. Your first day of school still exists in space-time. Your last birthday still exists. They're not gone, they're just in a different location along the fourth dimension. As real as places you haven't visited yet are real in space. Scientists call this the block universe, and it means the future already exists. Somewhere in the structure of space-time, tomorrow is as solid and real as yesterday. You haven't experienced it yet, for the same reason you haven't experienced what's happening in Tokyo right now. You're not there yet, but it exists. This raises an impossible question that physicists still cannot answer. If the future already exists, do you have free will? Is every choice you'll ever make already frozen in the cosmic ice of space-time? Or does consciousness somehow navigate between possible futures? We don't know. After a century of studying time, we genuinely don't know. But here's something even stranger. Time didn't exist before the Big Bang. Not because there was nothing to measure, but because before the Big Bang is a meaningless concept. Time itself was created in that first explosive moment, 13.8 billion years ago. Asking what happened before the Big Bang is like asking what's north of the North Pole. The question contains its own impossibility. Imagine trying to explain that to Isaac Newton, who believed time was absolute and universal, ticking away at the same rate everywhere in the cosmos. He thought God wound up the cosmic clock, and it ran forever, unchanging and perfect. Then Einstein came along and shattered that beautiful simplicity forever. Time runs slower when you move faster. This isn't philosophy or metaphor, it's measured reality. Put an atomic clock on an airplane, fly it around the world, and when you land, it will show less time has passed than an identical clock on the ground. The difference is tiny billionths of a second, but it's real. The faster you move through space, the slower you move through time. This means astronauts on the International Space Station age slightly slower than people on Earth. Not by much, over 6 months in orbit. An astronaut ages about 0.007 seconds less than they would on the ground. It's the smallest time travel in the universe, but it's genuine time travel nonetheless. They return to Earth having experienced less time, having fewer heartbeats, fewer breaths, fewer moments than everyone who stayed behind. But speed isn't the only thing that warps time. Gravity does too. The stronger the gravity, the slower time passes. Right now, time is moving faster for your head than for your feet. The difference is impossibly small, about 90 billionths of a second over your entire lifetime, but it exists. Your feet are infinitesimally younger than your head because they're deeper in Earth's gravitational well. GPS satellites have to account for this. They orbit 20,000 kilometers above Earth where gravity is weaker, so time runs faster for them, about 45 microseconds faster per day. If engineers didn't correct for this relativistic time dilation, GPS would become inaccurate by about 11 kilometers every single day. Your phone navigates reality by compensating for the warping of time itself. Near a black hole, time's distortion becomes extreme. If you could hover just outside a black hole's event horizon and watch the universe, you'd see the cosmos age billions of years in what feels like minutes to you. Stars would be born and die in fast forward. Galaxies would spiral and collide. The entire future of the universe would unfold before your eyes while your watch ticked normally. But to someone watching you from far away, you'd appear frozen. Your movements would slow to near stillness. A wave of your hand might take centuries from their perspective. You'd be trapped in slow motion while simultaneously witnessing eternity. This isn't science fiction. This is what Einstein's equations predict with mathematical certainty. The most extreme place in the known universe for time distortion is at the center of a black hole, the singularity. There, our equations break down completely. Time and space become so twisted that they might swap properties. Time becomes space-like. Space becomes time-like. What does that even mean? Honestly, we don't fully understand. The mathematics works, but defies translation into human experience. Here's something that sounds impossible. There may be no such thing as now. When you say now, you mean this present moment, right? But now on Earth and now on a distant star have no absolute meaning. Due to relativity, events that are simultaneous for you might not be simultaneous for someone moving at a different speed. The universe has no master clock, no cosmic now that applies everywhere. Two events can happen at the same time from one perspective, but at different times from another perspective. And both perspectives are equally valid. This means the universe doesn't divide neatly into past, present, and future the way our brains insist it does. Reality is far stranger than our intuition suggests. Time might not even be fundamental. Some physicists think time emerges from something deeper, something more basic. Just as wetness emerges from molecules of water but isn't a property of individual molecules. Time might emerge from quantum interactions but not actually exist at the quantum level itself. In quantum mechanics, the equations work perfectly fine without time. The Schrödinger equation, which describes how quantum systems evolve, treats time completely differently than it treats space. Some interpretations suggest that at the deepest level of reality, there is no time at all, just a timeless quantum state from which our experience of time emerges like a mirage. Carlo Rovelli, one of the founders of loop quantum gravity, wrote an entire book arguing that time doesn't exist. Not in the fundamental structure of reality, anyway. What we call time, he suggests, is just a way that creatures like us with limited perception and memories experience the universe's quantum states. Time is a feature of our ignorance, not a feature of reality. But you experience time undeniably, powerfully. Every moment of your life has been shaped by time's arrow, the fact that you remember the past but not the future, that eggs break but don't unbreak, that you age in only one direction. This arrow of time is so fundamental to your existence that imagining life without it seems impossible. Yet the laws of physics don't care which direction time flows. Nearly every equation in physics works exactly the same whether time runs forward or backward. If you filmed fundamental particles interacting and played the film in reverse, you couldn't tell the difference. The laws allow time to run either way. So why does time have a direction? Why do we remember yesterday but not tomorrow? Why does coffee cool but never spontaneously warm up? Why do we age? The answer lies in entropiety, measure of disorder in a system. The second law of thermodynamics states that entropy always increases, disorder always spreads. This is the only fundamental law of physics that distinguishes past from future. Imagine a drop of cream swirling into coffee. The cream starts concentrated, ordered, then it spreads, becoming more disordered, until it's evenly distributed throughout the coffee. You never see the reverse, coffee and cream spontaneously separating. That's entropy increasing, and it defines time's arrow. But here's the paradox. If the fundamental laws allow time to run backward, why does entropy only increase forward? The answer is probability. There are vastly more disordered states than ordered states. It's not impossible for cream and coffee to separate. It's just so staggeringly improbable that it would never happen, even if you waited longer than the Hoppered universe has existed. The Big Bang was the ultimate low-entropy state. The entire universe started in an incredibly ordered condition, and it's been spreading into disorder ever since. Every process you've ever witnessed, every sunrise, every breath, every thought is part of the universe's long journey from order to chaos. You exist because of entropy's increase. Your memories are made possible by entropy. When you form a memory, you increase the universe's disorder slightly. Your brain creates order, locally organizing neurons into patterns that encode experience, but this requires energy, and using energy increases entropy elsewhere. You literally cannot remember without contributing to time's arrow. This means time's direction and your consciousness are intimately connected. You experience time flowing forward because your memories work forward. If you could somehow reverse entropy, would you experience time backward? Would you remember the future and forget the past? These aren't just philosophical questions. They probe the deep connection between thermodynamics and consciousness. Some scientists think the arrow of time will eventually reverse. In the unimaginably distant future, when the universe reaches maximum entropy, a state called heat death, where everything is the same temperature and no energy flows anywhere, maybe time will stop having meaning. Or perhaps it will reverse, and the universe will begin contracting back toward order. But that's tens or hundreds of billions of years away. For now, for you, time flows in one direction only, forward, always forward. Yet even forward is strange when you examine it closely. You experience time as a series of discrete moments, now, like frames in a film. But is time actually made of moments, or is it smooth and continuous, infinitely divisible? Zeno of Ilia asked this question 2,500 years ago with his famous paradox. If you want to walk across a room, first you must walk halfway. Then you must walk half of the remaining distance, then half of what remains after that. Since you can always divide the remaining distance in half, you must complete an infinite number of steps. Therefore, Zeno argued, motion is impossible. Obviously, motion is possibly move all the time. But Zeno's paradox reveals something profound about infinity and time. It suggests that either time is not infinitely divisible, or infinity is stranger than our intuition suggests. Mathematics resolved this with calculus, showing that infinite series can sum to finite values. But the question remains, is there a smallest unit of time? Planck time is the shortest measurement of time that has any meaning in physics, about 10 to 43 seconds. That's a decimal point, followed by 42 zeros, and then a 1. It's so small that in 1 second, there are more Planck times than there have been seconds since the Big Bang. Light itself, traveling at the universe's speed limit, only crosses about 10 to 35 meters in 1 Planck time a distance, called the Planck length. Some physicists think Planck time might be the universe's clock tick, the smallest possible interval, the quantum of time itself. If true, time isn't smooth but granular, made of discrete moments, too small to detect, but fundamentally, their reality would be less like a flowing river and more like a film projected so fast the individual frames blur together. But we don't know if time is quantized. We have quantum mechanics for matter and energy, and general relativity for space and time, but they don't fit together. At the Planck scale, both theories claim to be in charge, and they give different answers. This is the central problem in physics today. We cannot reconcile quantum mechanics and gravity. String theory tries to solve this by suggesting that everything matter, energy, space, time, is made of tiny vibrating strings. Different vibration patterns create different particles. Time, in this view, emerges from the collective behavior of countless quantum strings. But string theory remains unproven, perhaps unprovable. A beautiful mathematical edifice that may or may not describe reality. Loop quantum gravity takes a different approach, suggesting space-time itself is woven from tiny loops of quantum fields. Time emerges from the way these loops interact and change. In this theory, at the smallest scales, time dissolves into something more primitive. Something we don't yet have words for, because our language evolved to describe the macroscopic world we experience. What's remarkable is that both theories, despite their profound differences, agree that time as we know it isn't fundamental. Time is something that emerges, that crystallizes out of deeper quantum reality, the way ice crystallizes from water. The smooth flow of moments you experience is like the solid surface of a table, seemingly continuous but actually made of atoms, with vast empty spaces between them. Your brain samples reality about 40 times per second, creating the illusion of smooth experience. Movies run at 24 frames per second and look continuous to you. Your consciousness processes time in discrete chunks, so small you don't notice the gaps. Every moment you experience is actually a constructed summary of many smaller moments, stitched together by your neural circuitry into the sensation of now. This means the present moment, the now you're experiencing instantaneous. Your now is about 3 seconds wide. That's how long it takes your brain to integrate sensory information, process it, and create the unified experience of the present. The words you just heard already happened, but your brain includes them in what feels like now. You live perpetually in the very recent past, mistaking it for the present. This 3-second window explains why music works. A melody requires you to hear notes in sequence, but also hold them together as a unified pattern. Your brain's time window lets you perceive the pattern, the relationship between notes separated by time. Without this window, music would just be isolated sounds. You'd hear notes, but never hear the song. It also explains why time seems to accelerate as you age. When you're 5 years old, 1 year is 20% of your entire life, a vast period packed with new experiences. When you're 50, 1 year is only 2% of your life, and fewer experiences are novel. Your brain compresses familiar experiences, making time seem to pass more quickly. Childhood summers felt endless because everything was new. You can slow down your experience of time by seeking novelty. Travel to new places, learn new skills, break routines. Your brain pays more attention to novel experiences, encoding them more richly, making those periods feel longer in memory. A week of vacation in an unfamiliar place feels longer than a week of routine at home, even though the clock time is identical. But clock time itself is arbitrary. We divide the day into 24 hours because ancient Egyptians divided daytime into 12 parts and nighttime into 12 parts. 12 is easily divisible and appeared in nature 12 lunar cycles in a year. But there's nothing fundamental about this division. We could have chosen 10-hour days or 16-hour days. Different cultures have measured time differently. The Mayans had multiple interlocking calendars of different lengths. Traditional Balinese culture uses a week that's only 6 days long. Some indigenous Australian cultures don't measure time linearly at all, but cyclically, seeing all events as part of returning patterns. Our modern obsession with precise time minutes and seconds is a recent invention, mostly created by industrialization's need to coordinate workers. Before trains, different cities kept different times based on their local noon. When the sun was highest, that was noon in that location. This meant noon in New York happened at a different clock time than noon in Philadelphia. Trains made this chaos impossible, so railroads invented time zones, dividing the world into bands where everyone agreed on the same time, regardless of where the sun actually was. Now we coordinate time with atomic clocks that measure the vibrations of cesium atoms. 9,192,631,770 oscillations define 1 second. These clocks are so precise they won't lose a second in 300 million years. We've measured time down to billionths of a second because GPS and internet infrastructure require that precision. Your phone's internal clock synchronizes with these atomic standards multiple times per day. Yet, even atomic clocks don't tick at the same rate everywhere. Remember, gravity slows time. The clock in your basement runs slower than the clock in your attic by about 90 billionths of a second per year. If you wanted clocks to stay perfectly synchronized, you'd need to place them at exactly the same height and keep them at exactly the same temperature, because heat affects atoms' oscillation rates. Scientists recently built optical clocks so precise they can detect the difference in time's flow between heights separated by just 1 centimeter. Stack 2 of these clocks 1 centimeter apart, and the top clock will tick faster than the bottom clock by a detectable amount. You could, theoretically, use these clocks to measure the height of a building, by comparing how fast time flows at different floors. This precision has revealed something unsettling. Earth's rotation is slowing down. Tidal friction from the moon is gradually lengthening our days. About 620 million years ago, a day was only 22 hours long. The moon was closer then, and its gravitational pull was stronger, creating enormous tides that dragged against Earth's rotation like a brake. In the distant future, Earth's rotation will slow until one day equals 1 month, about 50 current days long. The same side of Earth will always face the moon, just as the same side of the moon always faces Earth now. This is called tidal locking, and it's the end state of most orbiting bodies. The universe prefers synchronization. But even calling Earth's rotation slowing reveals our bias. We measure the slowing against atomic time, which we treat as absolute. From Earth's perspective, nothing is slowing, it's just rotating. Atomic processes have sped up from Earth's view. There's no absolute time against which to measure. Every clock defines time by its own rhythm. This leads to a profound realization. Time is what clocks measure. That sounds circular, but it's actually deep. There is no abstract time floating above reality. There is only the comparison between processes. Your heartbeat compared to Earth's rotation, compared to atomic oscillations, compared to light's travel. Time is relationships between changes, nothing more. Wheeler, the physicist who coined the term black hole, had a saying: time is nature's way of keeping everything from happening at once. It's a joke, but it contains wisdom. Without time, all events would be simultaneous. Cause and effect would be meaningless. Your birth and death would happen together. Time separates moments, giving reality its structure, its narrative, its possibility. But quantum mechanics reveals something strange. At tiny scales, cause and effect become fuzzy. Particles don't have definite positions until measured. They exist in superpositions, simultaneously in multiple states till an observation forces them to choose. During superposition, the particle has no definite history. It's as if time hasn't fully committed to a particular sequence of events yet. The famous double-slit experiment demonstrates this weirdness perfectly. Fire a single photon at 2 slits, and it somehow goes through both slits simultaneously, interfering with itself to create a pattern on a detector screen. But if you measure which slit it goes through, the interference pattern disappears. The act of measurement of determining the photon's history changes what happened. Some interpretations suggest the photon doesn't have a definite past until you measure it. Your observation in the present determines which history becomes real. It's as if the past is retroactively created by present observations. This is called retrocausality, the future affecting the past, and, while it sounds impossible, quantum mechanics seems to allow it. Delayed choice experiments prove this convincingly. Set up an experiment where you decide how to measure a particle after it's already committed to a path. Quantum mechanics predicts and experiments confirm that your future choice affects the particle's past behavior. The decision you haven't made yet influences what already happened. This doesn't violate causality in the usual sense because you can't use it to send information backward in time. The effects are statistical and only appear in averages across many particles. Still, it suggests time's relationship with cause and effect is more subtle than our everyday experience indicates. Einstein called this spooky action at a distance and hated it. He believed in a universe where past, present, and future were clearly separated, where causes preceded effects, where reality had definite properties, whether you looked or not. Quantum mechanics challenged all of this, and the universe sided with quantum mechanics every time. Bell's theorem proved that either particles can influence each other faster than light, or reality doesn't exist until measured, or both. Experiments continuously confirm Bell's predictions. This means either our understanding of time is wrong, or our understanding of locality is wrong, or our understanding of reality itself is wrong. Most physicists accept that reality at quantum scales simply doesn't behave like macroscopic reality, time included. In the many worlds interpretation of quantum mechanics, every quantum event creates branching timelines. Every time a particle is in superposition, the universe splits into multiple versions, one for each possible outcome. This means there are countless parallel timelines, where different versions of history unfolded from every quantum choice. If true, time isn't a single line but an endlessly branching tree. Every moment splits into countless futures, and all of them are equally real. There's a timeline where dinosaurs never went extinct. There's a timeline where you chose differently at every decision point in your life. These aren't hypotheticals in many worlds. They're actual parallel realities evolving alongside ours. This interpretation solves quantum mechanics paradoxes, but at the cost of multiplying reality infinitely. Most physicists find it extravagant, though some argue it's actually the simplest interpretation because it takes quantum mechanics math literally without adding extra assumptions. The universe calculates all possibilities, so all possibilities exist. But whether time branches or flows or simply exists as a static landscape, one thing is certain: your experience of it is unique to conscious beings. Rocks don't experience time passing. Atoms don't remember the past or anticipate the future. Something about consciousness creates the subjective flow of time. This is called the hard problem of time, explaining why time feels like it flows when physics suggests it doesn't. Some neuroscientists think consciousness is what creates time's flow, that the subjective experience of time passing is generated by your brain's particular way of processing sequential information. Time doesn't flow. Consciousness flows through time and mistakes its own motion for time's motion. Others argue the opposite, that time's objective flow creates consciousness, that awareness requires change, and change requires time, so consciousness cannot exist without time's passage. In this view, you are a pattern of information flowing through time, and your awareness is the pattern recognizing itself. We don't know. After thousands of years of philosophy and a century of precise physics, we still don't know why time feels like it flows, or what consciousness has to do with it. This mystery persists at the heart of human experience. What we do know is that you are a temporary arrangement of atoms that persist for decades before dispersing. Time is the dimension that allows your persistence. Without time, you couldn't maintain the pattern that is you. Without time, there would be no breathing, no heartbeat, no thoughts unfolding one after another. You are made of time as much as you're made of matter. And the atoms you're made of, they're billions of years old. The carbon in your cells was forged in ancient stars. The calcium in your bones was created in stellar explosions. You are made of stardust, and those stars existed billions of years before Earth formed. The matter you're composed of has experienced vast stretches of time, cycling through stars and planets and clouds of gas before briefly organizing into the pattern you call yourself. After you die, those atoms will continue. They'll become part of soil, plants, other creatures. They'll persist for billions more years, perhaps until the universe itself ends if it ends. Your matter is nearly eternal. Only your particular arrangement is temporary. Time gives you this moment, this breath, this thought. Without time, none of it would be possible. You are a pattern in time as much as a pattern in space, a four-dimensional structure with length, width, depth, and duration. To see you completely would require seeing not just your body now, but your entire timeline from birth to death, your world line through space-time. From outside time, if such a perspective were possible, you would look like a long snake stretching from the hospital where you were born to wherever you'll take your last breath. Every moment of your life would be equally present, equally real. A child and an elder simultaneously, all ages at once. This is what you look like in space-time, in the block universe, where time is a place rather than a process. But you can only experience one cross-section at a time, one moment, one now, moving along your world line like a train moving along tracks already laid. Whether the tracks ahead are fixed or whether consciousness somehow lays them as it goes, that question remains beautifully, maddeningly open. Some mystics claim they've experienced timelessness in meditation, moments where past and future dissolve, and only an eternal present remains. Neuroscience can detect this. Brain regions that track time and sequence show reduced activity during deep meditation. The experience is real, even if its interpretation is debatable. Your brain can turn down time's volume, proving that time's flow is at least partially constructed by neural activity. Psychedelic experiences often involve time distortion. Minutes feel like hours, or hours feel like seconds. Memories from childhood feel recent. The future seems already visible. Brain scans during these experiences show disrupted connectivity between regions that normally maintain your sense of temporal order. When those connections quiet, time becomes fluid, malleable, strange. This suggests time's consistency requires active neural work to maintain. Even ordinary life contains time distortions. When you're in danger, time seems to slow down. Your memory encodes events in higher detail during emergencies, and when you recall them, the richness of detail makes those moments seem longer than they were. You didn't actually experience slow motion, you just remember it that way because your brain was recording more carefully. Similarly, familiar commutes feel short while unfamiliar routes feel long, even if they take the same clock time. Attention and novelty stretch or compress subjective time. You are not a passive clock, but an active constructor of temporal experience. This construction begins in childhood. Children under age 3 have little sense of time passing. They live almost entirely in the present, which is why they have no episodic memories from that age. The development of autobiographical memory, the ability to remember events as happening to you at particular times, emerges around age 3 or 4. Before that, there is experience, but no experiencer, sensation, but no self-distinct from sensation. Learning to tell time is learning to overlay abstract symbols onto subjective experience. The clock says noon, but noon feels different on Sunday than Monday, in summer than winter, when you're hungry than when you're full. Clock time is public and shared. Experienced time is private and variable. You learn to live in both simultaneously, to translate between them. Modern life demands constant temporal precision. You schedule meetings to the minute. Trains arrive on time or they're late. Deadlines loom. This is historically new. For most of human existence, time was loose, approximate, governed by sun and season rather than by mechanical ticking. We've only been precisely time-conscious for a few generations. This precision has costs. Anxiety often relates to time worrying about the future, ruminating on the past, feeling rushed in the present. Depression can involve temporal distortion too, where the future seems impossibly distant or non-existent, where past and present merge into an unchanging now. Your sense of time and your mental health are deeply connected. But time also heals, as the saying goes. Given time, grief softens, wounds close, memories fade. This isn't just metaphor. Time allows biological and psychological processes to unfold. Healing requires duration. You cannot rush it, only allow it. Time is the space where recovery happens. In physics, time allows entropy to increase, order to become disorder. In biology, time allows evolution, the slow accumulation of tiny changes into profound transformation. In psychology, time allows learning, growth, the integration of experience into wisdom. Time is change, and change is possibility. Without time, the universe would be frozen, static, a single moment stretched infinitely with nothing to distinguish one part from another. Time gives reality its dynamism, its capacity for surprise, its unfolding plot. The story of the universe requires time to tell itself, and you are part of that story. Your few decades are a chapter in a narrative billions of years old and potentially infinite in duration. You didn't exist, then briefly you do exist, then you won't exist again. But while you exist, you experience the universe experiencing itself. You are time made conscious, duration made aware, the cosmos briefly waking up and asking, what is this? What am I? We don't have final answers. After all the physics and philosophy, time remains mysterious. But perhaps mystery is appropriate. Perhaps there are questions that deepen rather than resolve, that open rather than close, that lead not to answers but to better questions. What is time, really? It's the canvas on which reality paints itself. It's the dimension of change. It's the space between moments where causality operates. It's a property of space-time that warps near massive objects. It's an emergent phenomenon from quantum processes. It's a subjective experience constructed by consciousness. It's entropy's arrow. It's duration, sequence, simultaneity, history. It's all of these and more. Time is the mystery at the heart of existence, and we're living through it right now, moment by precious moment, wondering. Time travel is possible. You're doing it right now. Every second, you travel 1 second into the future. That sounds like a joke, but it reveals something profound. We're all time travelers, just moving in one direction at one speed, until we're not. Because speed changes everything. If you could board a spacecraft and accelerate to 99% of light speed, then travel for what feels like 1 year to you before returning to Earth, you'd find that 7 years had passed here. Your twin sibling would be 6 years older than you. You would have traveled into Earth's future by traveling through space very fast. This isn't theory, it's verified physics, confirmed by particle accelerators, where subatomic particles live longer when moving at near light speeds. The faster you move through space, the slower you move through time. You're always moving through space-time at the speed of light, but that motion is divided between spatial dimensions and the temporal dimension. Stand still in space, and all your motion is through time. You age normally. Move through space at high speed, and less of your motion goes through time. You age slower. It's as if the universe has a speed limit for total motion, and you're always going exactly that fast through the combination of space and time. Astronauts orbiting Earth experience this every day, moving at about 28,000 kilometers per hour. They age microseconds slower than people on the ground during their missions. Cosmonaut Sergei Krikalev spent so much time in orbit, over 800 days total, that he's traveled about 22 milliseconds into Earth's future compared to if he'd stayed on the ground. He's humanity's greatest time traveler so far, though his journey was modest. To travel years into the future, you'd need to approach light speed. At 99.999% of light speed, time dilation becomes extreme. Travel for one subjective year at that speed, and when you return to Earth, 224 years will have passed. Everyone you knew would be long dead. Civilizations might have risen and fallen. You'd emerge into a completely foreign world, having aged barely at all. But you could never go back. Traveling to the past is far more problematic than traveling to the future. The laws of physics seem to allow forward time travel through relativistic speed or gravitational time dilation. But backward time travel creates paradoxes that make physicists deeply uncomfortable. The most famous is the grandfather paradox. If you could travel to the past and prevent your grandparents from meeting, you would never be born. But if you're never born, you can't travel back to prevent their meeting. So you are born, so you can travel back, so you prevent them from meeting. So you're not born, an infinite loop of logical impossibility. Some physicists propose that paradoxes resolve themselves through the many worlds interpretation. When you travel to the past, you enter a parallel timeline. Preventing your grandparents from meeting creates a timeline where you're never born, but you came from a different timeline where you were born. Both timelines exist in the multiverse, so no paradox occurs. You just can't return to your original timeline. You've branched into a different history. Others suggest the Navikov self-consistency principle. Anything you do in the past must be consistent with the present you came from. If you try to kill your grandfather, you'll always fail somehow. The gun will jam, or you'll miss, or you'll kill the wrong person. The universe enforces consistency, allowing time travel but preventing paradoxes through increasingly unlikely coincidences. But can you actually travel backward through time? General relativity, surprisingly, says maybe. Einstein's equations allow solutions called closed time-like curves paths through warped spacetime that loop back on themselves. Follow one of these curves, and you'd return to your own past. One way to create a closed time-like curve is with a rotating black hole. The Kerr solution to Einstein's equations describes a black hole spinning so fast that space-time around it gets dragged along, twisted into a spiral. Near the event horizon of a maximally rotating black hole, space-time is so distorted that paths through it can loop backward in time. If you could somehow survive the journey ignoring the lethal radiation, impossible tidal forces, and general inhospitality of black holes, you might navigate through the twisted space-time near a rotating black hole and emerge before you entered. Theoretically, maybe, the math works. but the physics is nightmarishly complicated and probably impossible for anything to actually survive. Another theoretical method involves wormhole shortcuts through spacetime connecting distant points. Einstein and Rosen discovered these solutions in the 1930s, though they're often called Einstein-Rosen bridges. A wormhole could connect to points in space separated by vast distances, or it could connect to points in time separated by years or centuries. Here's how you'd build a time machine with a wormhole. Create or find a wormhole with two mouths. Keep one mouth stationary and accelerate the other to near light speed. Due to time dilation, the accelerated mouth ages slower. After enough time, the two mouths would be connected but exist at different times. Step into the aged mouth and you emerge from the younger mouth in the past. The problems are merely technical. First, we've never found a wormhole and don't know if they exist. Second, if they do exist, they probably collapse immediately unless held open with exotic matter with negative energy density, which we've never observed and which might violate fundamental laws. Third, calculations suggest that any wormhole you could send information or matter through would collapse the instant you tried, destroyed by the very particles attempting to traverse it. Stephen Hawking proposed the chronology protection conjecture. The laws of physics prevent time machines from being built, protecting causality from paradoxes. He half-joked that this makes the universe safe for historians, ensuring that the past remains fixed and unchangeable. Evidence for chronology protection includes the fact that quantum effects cause any closed time-like curve to become unstable and collapse. But some physicists aren't convinced. Kip Thorne, who won the Nobel Prize for detecting gravitational waves, has spent decades studying whether general relativity truly forbids time machines or merely makes them extremely difficult. His conclusion: we can't rule them out yet. The universe might allow time travel to the past under extraordinarily specific conditions we haven't discovered. One piece of evidence against past time travel is the Fermi paradox of time. If time travel to the past is possible, where are all the time travelers from the future? Why hasn't anyone from the year 3000 appeared at major historical events? Either time travel is impossible, or there are very good reasons future people don't visit the past, or they're extremely good at not being detected. Perhaps time travel requires technology so advanced that by the time civilizations develop it, they've also developed wisdom not to abuse it. Or perhaps you can only travel back to when the time machine was first activated. You can't travel to before the machine exists. This would explain the absence of visitors from the future. The first time machine hasn't been built yet. Or perhaps time travelers are here, but invisible to us, observing from carefully chosen moments in history, following strict non-interference protocols like the Prime Directive from science fiction. This isn't as far-fetched as it sounds. If you could visit the past, you'd want to minimize your impact to preserve the timeline that led to your existence. But probably, almost certainly, backward time travel is impossible, forbidden by physics in ways we don't fully understand yet. Forward time travel through relativity is definitely real, but traveling backward likely requires breaking the universe's fundamental rules. Time's asymmetry runs deep. The arrow of time points one direction for very good reasons, related to entropy and causality. Reversing that arrow might literally require reversing the entire universe's expansion, running the cosmic film backward until the Big Bang becomes the Big Crunch. And even then, who knows what would happen? What we can do is measure time with increasing precision, and those measurements reveal how strange time truly is. Atomic clocks have become so accurate that they've detected relativistic effects in everyday situations that seem impossibly mundane. Take two atomic clocks synchronized perfectly. Put one on the floor and one on a table a meter higher. Wait a few days. The clock on the table will be ahead by about 90 nanoseconds because time runs faster, farther from Earth's gravitational center. 1 meter of altitude creates measurable time dilation. This means your head ages faster than your feet by about 90 billionths of a second per day. Over 70 years, your head will be about 2 milliseconds older than your feet. Of course, your body is one integrated system, so this difference has no practical effect, but it's real. Time genuinely flows at different rates for different parts of your body. GPS satellites must correct for two opposite relativistic effects. They're moving fast, which slows their clocks by about 7 microseconds per day, but they're also in weaker gravity, which speeds their clocks by about 45 microseconds per day. The net effect is that satellite clocks run about 38 microseconds fast per day compared to clocks on Earth's surface. If engineers didn't correct for this, GPS would accumulate position errors of about 11 kilometers per day. Within days, GPS would be useless. Your phone compensates for Einstein's relativity thousands of times per day to tell you where you are. General relativity isn't abstract theory, it's in your pocket, keeping you from getting lost. But even GPS doesn't capture time's deepest weirdness. That requires quantum mechanics, where time behaves in ways that defy all intuition. In the quantum realm, energy and time are connected by Heisenberg's uncertainty principle. The more precisely you measure how long a quantum event takes, the less precisely you can know the energy involved. It's as if time and energy trade, certain teaming down one makes the other fuzzy. This allows particles to borrow energy from the vacuum for brief moments. An electron can temporarily gain energy, violating conservation of energy, as long as it pays the energy back quickly enough. The universe maintains its books on average, but allows temporary debts. These are called virtual particles, and they constantly blink in and out of existence throughout apparently empty space. The faster the borrowed energy is returned, the more energy can be borrowed. In time periods shorter than 10 to 21 seconds, particles can borrow enough energy to spontaneously create particle-hanticle pairs from nothing. They exist for an instant, then annihilate back into energy. This happens everywhere. Always empty space seethes with virtual particles appearing and vanishing too quickly to detect directly. Except we have detected them. The Casimir effect demonstrates virtual particles' reality. Place two metal plates extremely close together in a vacuum. Fewer virtual particles can fit between the plates than outside them due to the confined space. This creates a pressure difference. More virtual particles pushing from outside than inside. Then the plates are pushed together by apparently nothing, by emptiness itself. This proves that quantum uncertainty in time allows real physical effects. Time at quantum scales isn't a smooth parameter, but something fuzzy, probabilistic, strange. Cause and effect become blurred when events happen faster than about y minus 43 seconds, the Planck time. At the Planck scale, space-time itself becomes uncertain. Just as you can't precisely measure both a particle's position and momentum, you can't precisely measure both space-time's geometry and how it's changing. Space-time at the smallest scales might not be smooth at all, but foamy, bubbling with quantum fluctuations where tiny wormholes and baby universes appear and disappear. John Wheeler called this quantum foam. At scales below the Planck length, about 10 to 35 meters, the very fabric of space-time writhes with quantum uncertainty. Time, space, and geometry become meaningless in the conventional sense. What exists there? We don't know. Our equations break down. We need a theory of quantum gravity to understand it, and we don't have one yet. String theory suggests that at these scales, space-time has more dimensions than the 4 we experience. Perhaps 6 or 7 extra dimensions, curled up so small we can't detect them. Time might be just one of multiple temporal dimensions, with the others compactified beyond perception. We'd be like ants walking on a vast sheet of paper, unaware that the paper has thickness. But string theory remains unproven, perhaps unprovable. We can't build particle accelerators powerful enough to test it. We'd need an accelerator the size of the galaxy. So string theory remains beautiful mathematics that might or might not describe reality. It makes predictions about quantum gravity and the Planck scale that we cannot yet verify. Loop quantum gravity offers a different vision. Space-time is woven from quantum loops, and time emerges from their collective behavior, like temperature emerges from molecular motion. Individual loops don't experience time, but their interactions create the illusion of temporal flow at macroscopic scales. In this view, asking what happened before the Big Bang is like asking what's the temperature of a single atom. The question assumes time exists at a scale where it doesn't. Before the Big Bang, there was no before, not because nothing existed, but because time itself didn't exist. Time is a property of the universe, not a container the universe sits inside. Both theories agree on something radical. Time is probably not fundamental. It emerges from something deeper, something we don't have good words or concepts for because our brains evolved to navigate medium-sized objects, moving at medium speeds, not quantum foam or the birth of universes. This emergence explains why time behaves so differently at different scales. At human scales, time flows smoothly from past to future. At cosmic scales, time dilates and curves. At quantum scales, time becomes uncertain and possibly meaningless. Different levels of reality, different behaviors of time. Your experience of time, this moment, this now, this sense of flowing from past to future, merges from the collective behavior of trillions of quantum events in your brain. Each neuron firing is a quantum process, but billions of neurons firing in patterns create consciousness, and consciousness creates the sensation of time passing. So time is both real and constructed. The universe has temporal structure. Events happen in sequence. Causes precede effects. Entropy increases, but the flow, the passage, the sense of now moving forward that might be generated by consciousness, by the particular way brains model reality. This explains why time feels different in different states of consciousness. Deep sleep, where consciousness dims, seems to pass in an instant. You close your eyes and immediately open them, and 8 hours have vanished. Without consciousness to mark time's passage, duration collapses. Dreams distort time too. You can dream elaborate narratives that seem to last hours but occur during a few seconds of REM sleep. Your brain constructs temporal experience on the fly, unconstrained by external reality. In dreams, you experience time that never elapsed, pure, subjective duration, untethered from physics. Anesthesia creates even stranger gaps. General anesthesia doesn't just make you unconscious, it seems to stop consciousness entirely. People report no sense of time passing, not even the compressed instant of sleep. One moment you're counting backward, the next moment hours have passed and you're waking up. Those hours exist in the external world, but not in your experience. Your personal timeline has a gap where nothing happened for you, while everything continued for everyone else. This suggests consciousness and time are inseparable. Without consciousness, there's no experience of time. Without time, there's no consciousness. Requires change, memory, anticipation, the flow from moment to moment. You are a pattern in time, and time is a pattern in you. Neither fully exists without the other. Some philosophers argue this means time is entirely subjective, existing only in minds. But this goes too far. The universe had temporal structure long before consciousness evolved. Stars formed and died in sequence. Causality operated. Events happened one after another, even when nothing was around to experience them. What consciousness adds is the experience of time, the felt quality of duration, the sensation of now. Physics describes time's structure. Consciousness reveals time's texture. Both are real. Both are essential to understanding what time is. And what time is, ultimately, is change. Time is the dimension where change happens. In a universe without time, nothing could change. Everything would be frozen, static, eternal. Time liberates reality from stillness, allows before and after, permits becoming. Every transformation you've witnessed, seasons changing, plants growing, wounds healing, cities rising, happens in time. Change requires duration. The universe started simple, just energy and basic particles. After the Big Bang and became complex. Stars, planets, molecules, cells, brains, civilization. This journey from simple to complex required 14 billion years of time. You are made possible by time's vast duration. The atoms in your body were forged in stars that lived and died billions of years ago. Those stars needed time to form, time to burn, time to explode and scatter their elements. Then time for those elements to collect into new stars and planets. Then time for Earth to cool, for oceans to form, for life to begin and evolve through billions of generations, until eventually, improbably, magnificently your existence required almost the entire age of the universe to prepare. You are what 14 billion years of time can accomplish given the right conditions. You are time made flesh, duration crystallized into consciousness. The universe's long experiment with complexity becoming aware of itself. And you won't last. Time that made you will unmake you. Entropy will disassemble the pattern that is you, returning your atoms to simpler forms. Your body will decay, your molecules will disperse, your complexity will decrease as the universe's total entropy increases. You are a temporary local decrease in entropy, bought at the cost of greater entropy elsewhere. This is not tragic, it's physics. Everything complex is temporary. Stars burn out, galaxies disperse. Even black holes eventually evaporate through Hawking radiation, dissolving into particles over timescales that make the current age of the universe look like an eye blink. Given enough time, entropy wins. Always. But entropy's victory is also time's gift. Without entropy increasing, without the arrow of time, you couldn't exist. Life requires energy flowing from organized forms to disorganized forms. You eat food, organized molecules, and metabolize it into simpler molecules, using the energy released to power your thoughts and movements. You are an engine that runs on increasing entropy. Your thoughts themselves increase entropy. Every time you think, your neurons use energy, generating heat that disperses into your environment. You cannot think without making the universe slightly more disordered. Consciousness is literally powered by entropy increase. This means your awareness of time and your contribution to time's arrow are fundamentally linked. You experience time because you're a dissipative structure, something that maintains complexity by constantly consuming energy and increasing total entropy. Stop that process, and you stop existing as an organized entity. Time's flow and your existence are inseparable. Some physicists speculate that consciousness might even be necessary for time's arrow to exist. Without observers, without memory, could the universe have a past distinct from its future? This is contentious and possibly untestable, but it suggests time and awareness might be more deeply connected than we realize. What we know for certain is that your time is limited. You have decades, perhaps, if you're fortunate, a century at most. Those years are made of months, the months of days, the days of hours. About 700,000 hours in a full human lifetime. It sounds like a lot until you realize how quickly hours pass. Right now, as you listen to this, you're spending one of your hours, one of your limited collections. You're investing it in wonder, in learning, in the quiet pleasure of thinking about existence. That's a beautiful use of time, certainly better than many alternatives. Time is the ultimate non-renewable resource. You can acquire more money, more possessions, more knowledge. You cannot acquire more time. What you have is what you get. This makes every moment precious, even the ordinary ones, especially the ordinary ones. Most of your life isn't dramatic moments. It's breakfast and commutes, and doing laundry, and watching the sun set, and talking with people you love about nothing in particular. These small moments are your life. The time you spend in them is the time you have. There's no separate, more real life happening elsewhere. Buddhism teaches that clinging to past moments causes suffering, as does excessive focus on future moments. The only moment you ever truly have is now. The past is memory. The future is imagination. Only the present is real. This sounds mystical, but it's consistent with physics. The present here, now's all you can ever directly experience. Yet your now is about 3 seconds wide. Remember, you experience a sliding window of present moments, not a knife-edge instant. You exist, smeared across a few seconds of time, with your recent past still feeling like now, and your immediate future already anticipated. You are temporally extended, even in your immediate experience. This extension allows you to perceive change, to notice motion, melody, the flow of speech. If your now were truly instantaneous, you'd experience only frozen images with no connection between them. The width of your now your specious present is what allows you to experience time at all. Different animals likely experience different widths of now. A fly, with its faster neural processing, might experience a longer subjective now from the same objective duration. This is why flies are so hard to swatch. Her hand, moving normally fast to you, appears to move in slow motion to the fly. Its brain samples reality faster than yours, stretching the same clock time into more subjective moments. Conversely, very large animals with slower neural processing might experience a narrower now. A blue whale's consciousness might sample reality more slowly than yours, compressing duration into fewer distinct moments. We don't know for sure, we can't directly experience another creature's time, but neurological processing speed suggests this is likely. This means time's passage is not just relative between fast-moving objects, as Einstein showed, but also relative between different types of consciousness. Your now and a fly's now have different durations, even while occupying the same moments of clock time. Subjective time is species-specific, perhaps even individual-specific. You can manipulate your own subjective time to some degree. Meditation slows it by reducing the number of thoughts per clock second. Stimulants speed it by accelerating neural processing. Attention stretches moments by encoding them more richly. Distraction compresses them by encoding them sparsely. The most profound time manipulation is presence full attention to the current moment. When you're completely absorbed in an activity, time seems to simultaneously speed up and slow down. The experience feels timeless while you're in it, but in memory, it seems to have lasted longer than clock time would suggest. This is the flow state, where self-consciousness dissolves and you become one with what you're doing. Athletes describe this as being in the zone. Artists call it inspiration. Scientists call it deep work. Whatever the name, it's a state where normal time perception changes. You're so focused that you stop monitoring time, and paradoxically, this makes the experience feel both eternal and instantaneous. These states might represent consciousness touching something timeless. Not that time stops, but that your sense of duration, your constant measurement of how much time is passing pauses. You stop comparing now to past and future and simply exist fully in the unfolding moment. This is as close as conscious beings might get to experiencing reality as it is, rather than as filtered through temporal awareness. But you always return to time. You must. Living requires planning, remembering, coordinating with others who exist in time. You cannot maintain timeless awareness while navigating daily life. So you drop back into the flow of moments, into past and future, into the comfortable structure that time provides. And time provides tremendous structure. It organizes your life into narrative childhood, adolescence, adulthood, old age, beginning, middle, end. Your life is a story precisely because it unfolds in time. Remove time, and there's no story, just a jumble of events with no sequence. Stories require time. Characters must develop, which requires before and after. Plots must unfold, which requires causality. Meaning emerges from how events connect across duration. This is why we tell stories, to make sense of time, to find patterns in the sequence of events, to extract meaning from the flow of experience. Your own life is the story you tell yourself about who you are. It's constructed from memories, selective, edited, sometimes inaccurate, organized into a narrative that makes sense of your journey through time. This narrative isn't false, but it's also not purely objective. It's your interpretation of your timeline, the meaning you've extracted from your duration. Different cultures tell time differently, and this shapes how they tell their stories. Western cultures often see time as linear, moving from past through present to future in a straight line. This creates narratives of progress, development, goals achieved or missed. Many Eastern cultures see time as cyclic seasons, returning, generations repeating patterns, death and rebirth. This creates narratives of return, renewal, eternal recurrence. Neither view is more correct. They're different frameworks for organizing the same underlying reality. Indigenous cultures often see time as spiral, incorporating elements of both linearity and cyclicality. Events return but transformed. History echoes but doesn't repeat exactly. This creates narratives where past and present coexist, where ancestors remain present, where time is less a line or circle and more a living relationship. Modern physics suggests time might be none of these shapes. In the block universe, time is a landscape where all moments exist simultaneously. From outside spacetime, if such a view were possible, time would have no flow, no direction, no preferred shape. It would simply be a dimension, like length or width. But you experience time from inside it, and from inside, time definitely flows. Past recedes, future approaches, present slides along. This experience is real, even if it's generated by consciousness, rather than built into space-time's fundamental structure. Perhaps the question isn't what is time, really, but what is time for us? Because ultimately, we don't experience time as it might exist abstractly. We experience time as filtered through consciousness, culture, biology, physics. We experience human time measured in heartbeats and seasons, in memories and hopes, in the stories we tell ourselves about where we've been and where we're going. And human time is precious precisely because it's limited. You get one journey through time, one timeline, one story. It's yours completely. No one else can experience your particular sequence of moments. Your timeline is unique in all the universe's history and future. This makes your time valuable beyond measure, more valuable than anything you could purchase or possess, because your time is your life, literally. How you spend your hours is how you spend your existence. Right now, you're spending time on wonder, on pondering mysteries, on letting your mind expand into questions that have no easy answers. That's time well spent. In a universe where time seems to be heading toward maximum entropy and heat death, where complexity will eventually dissolve back into simplicity, you're using your brief window of consciousness to appreciate the magnificent strangeness of it all. That might be the deepest purpose of consciousness: to appreciate, to witness, to look at the universe and say, this is extraordinary. You are the universe, looking at itself with wonder. And that wonder is only possible because you exist in time, able to distinguish what is from what was and what might be. Time gives you this gift, the ability to change, to grow, to become something you weren't. You are not the same person you were 10 years ago. Your cells have been replaced multiple times. Your thoughts have evolved. Your understanding has deepened. Time has transformed you while maintaining continuity. You're different, yet somehow still you. This is time's greatest paradox and greatest gift. It allows change while preserving identity. You flow like a river. The water is always different, but the river remains. Heraclitus said you cannot step in the same river twice, for it's not the same river, and you're not the same person. But also, beautifully, essentially is the same river, and you are the same you. Both things are true simultaneously. You are a pattern that persists through time by constantly changing. You maintain yourself by metabolizing, replacing, renewing. You stay alive by flowing, by being dynamic. If you froze in place, no change, no time, you'd stop being you. You are verbs, not nouns, a process, not an object, an ongoing event rather than a static thing. And this process has been happening for 14 billion years in various forms. The matter you're made of has always existed in some configuration. Before it was you, it was food, soil, plants, ancient organisms, minerals, stellar dust, hydrogen in the early universe. Your atoms have been on quite a journey through time. After you, they'll continue. They'll become part of other forms, other patterns, other brief organizations, before dispersing again. The universe recycles endlessly, at least until maybe it reaches heat death, and all recycling stops. But that's so far in the future, it might as well be infinity from your perspective. For now, for your lifetime, you are these atoms, arranged in this particular configuration, experiencing time from this particular viewpoint, wondering what it all means. And maybe that wondering, that questioning is meaning enough. Maybe consciousness exists to ask these questions, to probe reality's nature, to push against the limits of understanding. Maybe time exists to give consciousness enough duration to develop these questions. Or maybe time exists for no reason at all. Maybe it's just a feature of reality, neither more nor less mysterious than space or energy, or the fact that anything exists instead of nothing. Maybe asking, why does time exist, is like asking, why does existence exist? A question that leads to vertigo rather than answers. But the vertigo is beautiful in its own way, standing at the edge of understanding and looking into mystery, knowing that for all our physics and philosophy, time remains fundamentally strange. That's not a failure of knowledge, it's an invitation to wonder. So wonder, rest in the questions, let them wash over you gently as you drift toward sleep. Time will continue with or without your understanding of it. The universe will keep unfolding its moments, one after another, in whatever pattern it follows. And you'll continue to, moving through your timeline, spending your hours, living your story. You'll wake tomorrow into a new day, which is really just the continuous present extended further, which is really just another cross-section through your four-dimensional world line, which is really just another moment of consciousness experiencing time's strange flow. However you think about it, you'll be there, experiencing it, alive in time. And that's wonderful enough. The universe is dying. Not today, not tomorrow, not for trillions upon trillions of years, but eventually, inevitably, time will lead everything toward a final stillness. This isn't pessimism, it's thermodynamics. And strangely, there's something peaceful about understanding time's ultimate destination. The heat death of the universe is the most likely ending to time's story. In this scenario, entropy reaches its maximum possible value. Every star has burned out. Every black hole has evaporated. All matter has decayed into its simplest forms. Energy is spread so evenly throughout space that no differences exist anywhere, no hot or cold, no dense or sparse, no here or there. Just uniform, cold, motionless existence at a temperature barely above absolute zero. When this happens, perhaps in 10,100 years, a 1 followed by 100 zeros, time doesn't exactly end, but it becomes meaningless. Time is the dimension where change happens. Remember, in a universe at maximum entropy, nothing can change anymore. No energy flows, no processes occur. The universe reaches equilibrium and stays there forever. Forever is a long time to be unchanging. Some physicists speculate that in this far future, even protons might decay. Currently, we think protons are stable, they last indefinitely. But some theories suggest that given enough time, even protons break down into lighter particles and energy. If true, after about 1040 years, all the matter that currently exists will have dissolved into radiation and exotic particles. Then the universe would be mostly photons and neutrinos, spreading ever further apart as space continues expanding. These particles would stretch to longer and longer wavelengths, carrying less and less energy, until they're barely distinguishable from empty space itself. The universe would become a thin, cold soup of nearly motionless quantum fields. Black holes would be the last complex structures to survive. They'd hang on in the expanding darkness, slowly evaporating through Hawking radiation. A black hole, the mass of the Sun, would take 1067 years to evaporate completely. The supermassive black holes, at the centers of galaxies billions of times more massive, would last until about 10,100 years. When the last black hole finally evaporates in a faint burst of radiation, that might be time's final meaningful event. After that, just endless expansion and cooling. No structures, no change, no events to mark time's passage. The universe would enter what's called the dark, irreternal, empty, cold. But this assumes the universe keeps expanding forever, which seems likely based on current observations. Dark energy, the mysterious force causing the universe's expansion to accelerate, appears to be pushing everything apart faster and faster. If this continues, eventually, galaxies will be so far apart that light from one can never reach another. Each galaxy will be alone in its own isolated bubble of observable space. Trillions of years from now, any civilization living in a galaxy will look out at the night sky and see nothing. Just blackness. The expansion of space will have carried all other galaxies beyond their cosmic horizon. They'll be cosmologically alone, unable to detect any other structure in the universe. They won't even be able to discover that the Big Bang happened. The cosmic microwave background radiation will have redshifted into undetectability. These future beings will think they live in an eternal, unchanging universe consisting of only their galaxy, surrounded by infinite emptiness. They'll have no evidence that space is expanding or that time had a beginning. The universe will have erased its own history through expansion. This is time playing a cosmic trick, hiding the truth from distant observers, making the finite look infinite, the beginning look eternal. It's a reminder that our position in time is special. We live in an era when the universe still reveals its history. We can see the Big Bang's afterglow. We can measure cosmic expansion. We can reconstruct time's story back to its beginning. That beginning, the Big Bang, is time's greatest mystery. Not because we don't know what happened during the Big Bang, but because we don't know what it means to say time began. In one sense, asking what happened before the Big Bang is meaningless. Time itself began with the Big Bang. There is no before, because before is a temporal concept and time didn't exist yet. It's like asking what's north of the North Pole. The question assumes a direction that doesn't exist there. But in another sense, maybe something existed in a timeless state before time began. Some theories suggest our universe buddied off from a parent universe. or emerged from a quantum fluctuation in a larger multiverse, where different regions have different laws of physics and different numbers of dimensions. In eternal inflation theory, our Big Bang was just one bubble forming in an endlessly inflating quantum foam. New universes are constantly being created, each with its own Big Bang, each with its own timeline. Time in our universe began 13.8 billion years ago, but the larger multiverse might be eternal, no beginning, no end, just endless creation of new time bubbles. This is deeply speculative, perhaps untestable. We can't see outside our universe. We can't detect these other time bubbles, even if they exist. But mathematically, the equations that describe inflation suggest it's eternal once it starts. And if it's eternal, the question becomes, why did inflation start? What began the process that creates beginnings? Some physicists think there might be no ultimate beginning. Time might be infinite in the past, stretching backward forever in some form. Stephen Hawking proposed that very early in the Big Bang, time might have been more like space, a dimension you could move in any direction. In this model, asking what happened before the Big Bang is like asking what's south of the South Pole. You can keep moving, but you'll just circle around without ever finding a before. Others suggest time might be cyclic. The universe expands, reaches maximum size, then contracts back into a big crunch, which triggers a new Big Bang, which expands into a new universe, which eventually contracts again. In this model, time has no beginning or end, just endless cycles of expansion and contraction, like a cosmic heartbeat that's been beating forever. We don't know. After all our physics and all our observations, we genuinely don't know if time had a beginning or if it extends infinitely into the past. Both possibilities seem impossible, yet one must be true. Either time started from nothing, which seems absurd. Time has always existed, which also seems absurd. This is what philosophers call an antinomia situation, where two contradictory conclusions both seem logically necessary. Time must have either begun or always existed. Both options violate our intuitions, yet no third option appears available. We're stuck in conceptual paradox. Perhaps our intuitions are simply wrong. We evolved to understand medium-sized objects moving at medium speeds in weak gravity with high entropy. We didn't evolve to understand the origins of time itself. Our brains might lack the conceptual capacity to truly grasp what happened at time's beginning, just as a dog lacks the capacity to understand calculus. But we can still describe it mathematically. The equations work even when our intuition fails. General relativity predicts a singularity at the Big Bang, a point where density and temperature become infinite and the equations break down. But most physicists think this singularity isn't real. It's a sign that general relativity fails at extreme-looking conditions and needs to be replaced with quantum gravity. When we finally develop a complete theory of quantum gravity combining general relativity and quantum mechanics successfully, it should tell us what really happened at the Big Bang. Maybe it will show that the singularity is smoothed out by quantum effects. Maybe it will reveal that time emerges gradually from some more fundamental quantum state. Maybe it will show something we can't even imagine yet. Until then, the beginning of time remains mysterious. Appropriately so, perhaps. Some questions should stay open, inviting wonder rather than closing with answers. What we do know is that time once begun, has been generous. 13.8 billion years from the Big Bang to now. Enough time for stars to form, for planets to coalesce, for life to emerge and evolve into consciousness, for consciousness to develop science and ask these questions. Time has given the universe space to create beauty, complexity, awareness, and time continues, giving right now. As you listen to these words, time is creating new moments. Stars are forming in distant nebulae. Planets are orbiting their suns. Perhaps life is emerging on some of them. Perhaps other conscious beings are pondering time's mysteries just as you are, wondering what it all means. Time connects you to all of this. The atoms in your body were forged in stars that died billions of years ago. The calcium in your bones, the iron in your blood, the oxygen you're breathing, all created in stellar furnaces and scattered by supernova across space. You are made of star stuff, as Carl Sagan said, and those stars existed in time's deep past. But you also extend into the future. The atoms that currently compose you will continue existing after you die. They'll become part of soil, plants, animals, perhaps other humans, eventually. Your matter is nearly eternal, cycling through countless forms across time. Only your particular pattern, the specific arrangement that is you, is temporary. This is both humbling and comforting. You are not permanent, but you're part of something that is. Your brief decades are one small chapter in matter's long story. Before you were born, your atoms had already existed for billions of years. After you die, they'll continue for billions more. You are a temporary eddy in the universe's flow. And during your eddy, you get to experience time's passage. You get to witness change, growth, transformation. You get to remember the past and imagine the future. You get to stand in the present and marvel at it all. That's an extraordinary gift: consciousness, experiencing time, matter, becoming aware of its own duration. Most of the universe never experiences time. Rocks don't. Stars don't. Black holes don't. They exist in time. They change over time, but they don't experience it. They have no memory of past or anticipation of future. They simply are, moment after moment, unconscious of their own duration. You're different. You know you exist in time. You know you're changing. You know you won't last forever. This knowledge shapes everything about your experience. It creates urgency, the sense that time is precious because it's limited. It creates meaning, the understanding that your choices matter because you only get one timeline. And it creates something beautiful, the awareness of transience, the recognition that this moment, right now, will never come again, that tomorrow you'll be slightly different than today, that everyone you love is temporary, every experience is fleeting, every moment is unique and unrepeatable. Japanese culture has a word for this: mono no aware, the gentle sadness of impermanence, the bittersweet awareness that beauty is enhanced by its transience. Cherry blossoms are precious precisely because they bloom for only a week. A sunset is stunning partly because it will soon give way to night. Your life is valuable because it doesn't last forever. If you were eternal, unchanging, immortal, would anything matter? Would any moment feel special? Or would infinite time make every moment disposable, interchangeable, meaningless? Perhaps finitude is what creates value. Perhaps time's arrow, pointing toward your eventual ending, is what makes your middle precious. Death is time's destination for every living thing, not just humans. Every organism, every species, eventually, currently, About 150,000 people die every day. That's 2 deaths per second, 100 million per year. Each one is the ending of a unique timeline, a particular perspective on existence that will never occur again. Some people find this thought terrifying. Others find it liberating. You don't have to be perfect or accomplish everything, or see everything, or become everything. You just have to live your particular timeline, make your particular choices, have your particular experiences. Your life doesn't need to be epic or historic, it just needs to be yours, genuinely lived. The universe won't remember you. In 1 trillion years, all evidence that you existed will have vanished, completely. No monuments, no records, no traces. Heat death will eventually erase everything humanity has ever done, or thought, or built. From the universe's perspective, your life is infinitesimally brief and utterly forgettable. But from your perspective, your life is everything. It's the only existence you'll ever experience. Your decades are your infinity. Your timeline is your cosmos. The universe might not remember you, but you get to remember the universe, to witness it, appreciate it, marvel at it. That's a fair trade. And during your brief witnessing, you affect things. You change the people around you. You alter their timelines through your interactions. Every conversation you have, every kindness you show, every connection you make, these ripple through time in ways you can't fully predict or measure. Think about the people who've influenced you. Parents, teachers, friends, strangers, who said something meaningful at just the right moment. They shaped your timeline, altered your path through time. And you do the same for others, often without realizing it. Your existence changes other existences. Your timeline intersects other timelines, and those intersections matter. In this way, you extend beyond your own lifespan. You live on in your effects, in the people you've touched, the ideas you've shared, the love you've given, not forever, not ultimately, but for a while, for a few generations, perhaps. Your influence persists in the timelines of others before eventually fading into the background noise of history. This is a gentler kind of immortality than physically lasting forever. You accept your finitude while recognizing that your life creates ripples that extend beyond it. You matter because you affect the present, which shapes the future, which creates tomorrow's history. You're a contributing thread in time's vast tapestry. Different philosophical traditions handle time's finitude differently. Epicurus, the ancient Greek philosopher, argued that death cannot harm you because when death exists, you don't exist, and when you exist, death doesn't exist. Therefore, you and death never meet. Fear of death, he suggested, is irrational. It's fearing something you'll never experience. Buddhist philosophy teaches impermanence as fundamental truth. Everything changes, nothing lasts. Clinging to permanence causes suffering. The solution isn't to fear time's passage, but to accept it fully. Each moment arises and passes. Trying to hold on to them is like trying to hold water in your hands. It just flows away faster. Existentialist philosophers like Heidegger argued that awareness of mortality actually gives life its authentic meaning. Knowing you'll die forces you to confront what truly matters to you. It strips away pretense and reveals what you genuinely value. Your finitude focuses your choices, making them meaningful, precisely because you can't do everything. Stoic philosophy suggests focusing only on what you can control, your thoughts, choices, and responses, and accepting what you can't control, including time's passage and eventual death. Marcus Aurelius wrote, "You could leave life right now. Let that determine what you do and say and think, not morbidly, but as a reminder to live intentionally." These are different approaches to the same fundamental reality. You exist in time, and time will eventually end for you. How you relate to this truth shapes your entire life. Fear it, and you spend your time anxious. Deny it, and you waste your time on trivialities. Accept it, and you can spend your time on what genuinely matters to you. What matters varies by person, by culture, by circumstance. There's no universal answer, but time itself doesn't judge. It passes equally for the ambitious and the content, the famous and the unknown, the happy and the suffering. Time is neutral, offering its moments to everyone without preference. You receive the same 24 hours each day as every other human. What differs is how you spend those hours, where you direct your attention, what you prioritize, how you engage with each moment. Time is the currency you spend on your life. How you spend it determines what your life becomes. Right now, you're spending time on wonder and contemplation. You're investing your precious hours in understanding reality's deepest patterns. That's a worthy use of time, engaging your consciousness with the magnificent mysteries of existence. Some spend their time accumulating possessions or status or experiences. You're spending it on awareness, understanding, appreciation. Neither use is inherently better. Time doesn't care, but you might care when you look back on your timeline from its end. What will you wish you'd spent more time on? What will you be glad you made time for? These aren't hypothetical questions. They're invitations to align your present choices with your deepest values. Because present choices are all you have. The past is fixed. You can't change what's already happened, only how you interpret and relate to it. The future is uncertain. You can plan and prepare, but you can't control what hasn't happened yet. Only the present is actionable, influenceable, alive. This doesn't mean ignoring past or future. Memory and anticipation are essential to human consciousness, but it means recognizing that you always act in the present. Even when planning for the future, you're planning now. Even when learning from the past, you're learning now. Now is where you have power, where your choices manifest, where time becomes life. And now keeps arriving. It's inexhaustible. In one sense, there's always another now coming. But it's finite. In another sense, you only get so many nows before your timeline ends. This tension between the endless arrival of moments and the limited number of total moments creates time's peculiar urgency and preciousness. Mindfulness practices train attention on this present now, not to reject past or future, but to fully inhabit wherever you actually are in time, which is always here and now. When eating, fully eat. When walking, fully walk. When resting, fully rest. Stop dividing your attention between now and then, between here and elsewhere. This is harder than it sounds. Your mind constantly wanders to past regrets or future anxieties. You relive conversations from yesterday, rehearse conversations for tomorrow, and miss the conversation happening now. You exist physically in the present while mentally time-traveling to memories and fantasies. But when you do manage to be fully presentially here, really now, time transforms. It seems to expand. A few minutes of full presence feel longer and richer than hours of distracted half-attention. Quality of time isn't measured just in duration, but in depth of experience. Musicians know this. When completely absorbed in playing, time vanishes and also intensifies. Athletes describe similar states. The game slows down. They see everything clearly. They act without thinking. Artists lose hours in what feels like minutes while creating something that contains those hours compressed into paint or words or melody. These are moments when you and time harmonize. You're not fighting time's passage or wishing it were different. You're flowing with it, moving through it gracefully, experiencing it fully. This might be as close as humans get to transcending time while remaining temporal beings. But you can't stay in flow forever. Time carries you back to ordinary consciousness, to deadlines and schedules, and the measured progression of moments. This is fine. Life requires both timeless immersion and temporal navigation, losing yourself and finding yourself, flow and structure. The structure that time provides is actually liberating in its own way. Knowing you have limited time focuses your energy. Deadlines create motivation. The rhythm of days and seasons provides pattern and predictability. Without time's structure, everything would happen at once or never, which amounts to the same thing: chaos without sequence, action without consequence. Time is also what allows healing. Physical wounds need time to close. Psychological wounds need time to integrate. You can't rush recovery. You can only provide conditions and allow time to do its work. Time heals all wounds is an oversimplification, but time does enable healing by allowing processes to unfold, perspectives to shift, intensity to fade. Grief particularly requires time. The acute pain of loss doesn't disappear, but it changes. Given time, you integrate the loss into your timeline. The person you lost becomes part of your past, cherished in memory rather than mourned as recently absent. Time doesn't erase grief, but it transforms it from raw agony into tender remembrance. This transformation is only possible because you exist in time. The you of 6 months from now will have 6 more months of experience, 6 more months of processing, 6 more months of living beyond the loss. You'll be different because time will have changed you. That's time's gift to the grieving, the promise that this moment isn't permanent, that change is coming, that future you will have more perspective than present you. But time also means you'll lose more people. Everyone you love exists in time, and time leads to war, death for all of them as surely as for you. This is perhaps time's cruelest feature. It guarantees loss. The price of loving someone is knowing you'll lose them eventually, either through their death or yours. Some people choose not to love deeply to avoid this pain. But this just exchanges one pain for another, the acute pain of loss for the chronic pain of isolation. Time will pass either way. You can't avoid time's losses by refusing to engage with time. You can only choose whether to spend your time connected or protected. Most people choose connection despite knowing it guarantees future pain. They love their children knowing they'll worry about them for decades. They befriend others knowing those friendships might end through conflict or distance or death. They commit to partners knowing that till death do us part is a promise, not a possibility. This is courage loving across time while knowing time's inevitable arc. It's saying that the present joy is worth the future grief. That the years of companionship justify the eventual loss. That being together for a while is better than being alone forever. And everyone you love is experiencing time alongside you. Your timelines run parallel for a while, intersecting daily, influencing each other. Their now and your now overlap. You share this present moment, this particular configuration of the universe, this brief window of existence. That sharing is what creates relationship, community, love. When someone dies, their timeline ends, but yours continues. You carry them in your memory, your timeline containing the record of their timeline's intersection with yours. In this way, they persist in you not physically, not consciously, but as information, as influence, as a shaping force that made your timeline different than it would have been without them. This is the closest thing to immortality that actually exists, persistence in the timelines of others through the changes you created in them. Not living forever, but having lived in a way that affected other lives, that left traces in other timelines that extend beyond your own. Your timeline will end. If you're fortunate, it will be long, perhaps 90 or 100 years. If you're unlucky, it might be shorter, but whatever its length, it will be finite. You'll have a last moment, a last breath, a last thought. And then you'll transition from being a present participant in time to being a past event in time, someone who was rather than someone who is. What happens after death? Does consciousness continue in some form? Does time continue for you in some way? Every culture has beliefs about this, but nobody knows for certain. Death remains the great mystery, the one experience none of the living have reported back from. Maybe consciousness ends completely when your brain stops functioning. Maybe there's some form of continuation, incarnation, heaven, transformation into another state of being. Maybe the question itself is wrong, based on false assumptions about what consciousness is and how it relates to time. Physics suggests that in some sense, you never truly die in the block universe. If all moments in time exist eternally in space-time, then every moment of your life exists forever at its particular location in the fourth dimension. You, right now, you as a child, you in old age, all exist permanently as four-dimensional structures in space-time. From this perspective, you're not just a temporary flash of existence, but an eternal thread woven through space-time. You always exist at your particular coordinates, experiencing your particular moments. Death isn't cessation, but just the end of your timeline, the boundary of your four-dimensional self. This is cold comfort, perhaps. You don't experience your eternal existence in space-time. You experience the flow of moments, and that flow will end. But it's a reminder that your existence, however brief, is real and permanent in the universe's structure. You happened. You are part of time's landscape forever, even if consciousness doesn't continue past death. Or maybe consciousness does continue in ways we can't detect. Quantum mechanics shows that observation affects reality at tiny scales. Some interpretations suggest consciousness plays a role in collapsing quantum probabilities into definite outcomes. If consciousness is somehow fundamental to reality, rather than merely emergent from brain activity, maybe it persists beyond individual brains. This is extremely speculative, probably unprovable, possibly wishful thinking, but it's also not definitively ruled out by known physics. We don't understand consciousness well enough to say whether it's purely physical or whether it has aspects that might transcend physical death. The honest answer is, we don't know. What we do know is that fear of death is natural and nearly universal. Humans are probably the only animals aware they will die. This awareness shapes everything: culture, religion, art, science, philosophy. We build monuments to outlast us. We create art to preserve beauty beyond our lifetimes. We have children to continue our genetic line. We tell stories to pass knowledge through generations. All of this is motivated partly by awareness of mortality. We know our time is limited, so we try to extend our influence beyond it. We know we'll die, so we create things that won't. We know we're temporary, so we attach ourselves to things we hope are permanent. But maybe the right relationship with mortality isn't to fight it or transcend it, but to accept it fully. To say, yes, I will die. Yes, my time is limited. Yes, everything I build will eventually crumble. And nevertheless, I choose to live fully, love deeply, engage authentically with the moments I'm given. This acceptance doesn't mean resignation or passivity. It means living with clear eyes, without illusions about permanence, making choices based on genuine values rather than desperate attempts to deny mortality. It means spending your time on what truly matters to you rather than on what you think should matter or what others expect to matter. What matters to you? Not hypothetically, not abstractly, but actually where do you spend your time? What do you think about when your mind wanders? Who do you want to be with? What activities make you lose track of time? These reveal your true values more accurately than your stated values. And you can change how you spend your time. Not completely. You have obligations, constraints, necessities. But within those boundaries, you have choices. You can redirect your attention, reprioritize your commitments, reallocate your hours. Time is finite, but it's also flexible within your particular constraints. The time you have left is unknown. It might be decades or days. You can't know. This uncertainty is frustrating but also liberating. Since you don't know when your timeline ends, you can't perpetually postpone living fully. You might not have later. You have now. This isn't meant to create anxiety, but to clarify. Your time is precious because it's limited and uncertain. Therefore, spend it consciously. Choose deliberately. Say yes to what enlarges you and no to what diminishes you. Live in a way that if you looked back from the end of your timeline, you'd feel you spent your time well. What does spending time well mean? Only you can answer that. It's different for everyone. For some, it's creating art or advancing knowledge or building things or helping others. For others, it's raising children or cultivating inner peace or simply experiencing beauty and sharing love. There's no universal metric for a life well lived, but whatever your particular answer, it requires time. It requires duration, sequence, the unfolding of moments. Without time, you couldn't become anything, achieve anything, experience anything. Time is the dimension where your life happens. How you navigate that dimension determines what your life becomes. And you're navigating it right now. This moment is part of your life. These words are part of your timeline. This quiet contemplation, this gentle wondering about existence, this is you spending your time making choices about where to direct your attention, what to think about, how to be, lose, on pondering what is perhaps unponderably vast and subtle. On letting your mind stretch into questions that may have no final answers. That's beautiful. That's consciousness using its brief window to marvel at the context it exists within. Time gives you this opportunity, the chance to think about time, to be aware of awareness, to witness the witnessing. You're the universe examining itself, time studying time. Consciousness exploring consciousness. This recursive self-reflection is extraordinary, perhaps unique in the cosmos, certainly rare. Billions of years of cosmic evolution led to you lying here, thinking these thoughts. Stars lived and died to create your atoms. Planets formed and evolved to provide your environment. Life struggled for billions of years to develop consciousness sophisticated enough to ask these questions. All of that required time, vast, patient, accumulating time. And now time has produced you, a being capable of understanding that you exist in time, that time itself is strange and mysterious, that your existence is both infinitesimally brief and utterly unique. You're a way for the universe to know itself, and that knowing required all of time's history to develop. So perhaps the meaning of time is this: it's the dimension where complexity can emerge, where consciousness can develop, where the universe can wake up to itself. Time transforms simple into complex, unconscious into conscious, chaos into order, into greater chaos, into new order. Time is the process by which possibility becomes actuality. Your life is possibility becoming actuality. Every moment you choose from the range of possible actions available to you, and your choice makes one possibility actual, while all others remain forever unmanifested. Your timeline is the specific path you chose through the vast landscape of possible timelines you could have had. Were different choices possible? Do you have free will, or is your path determined by prior causes stretching back to the Big Bang? This question remains unresolved. Physics is deterministic at large scales, but probabilistic at quantum scales. Whether that quantum randomness allows for genuine free will is debated endlessly among philosophers and physicists. But regardless of whether your choices are truly free or completely determined or some mixture, you experience them as choices. You feel like you're making decisions, and you can't live as if you aren't. So perhaps the question of free will is less important than the curiance of agency, the sense that how you spend your time matters, that your choices shape your timeline. And your timeline is precious, unique, unrepeatable. No one else will ever have your exact sequence of experiences, your particular perspective on existence, your specific journey through time. You are the only person who will ever live your life. That makes it infinitely valuable, even if it's also infinitely brief from the cosmos's perspective. The universe is vast, perhaps infinite in space, definitely enormous in time. Against that vastness, your few decades seem negligible. But they're not negligible to you. They're everything. They're all the existence you'll ever directly experience. The universe might be vast, but your life is complete in itself, whole in its own context, meaningful on its own terms. This is perhaps the final answer to what is time, really. Time is context. It's the framework where meaning emerges, where change happens, where you exist. Without time, there would be no you, no experience, no consciousness, no questions, no wonder. Time is the gift the universe gives itself, the dimension where it can unfold, develop, transform, and eventually look at itself with wonder through eyes like yours. Time is possibility. Time is change. Time is the stage where the cosmic drama plays out, and you're part of that drama. A brief scene, perhaps, but fully present while it lasts. Your scene matters because all scenes matter. The universe doesn't rank its moments. A supernova and a sigh are equally part of time's tapestry, equally real, equally woven into the structure of what is. So rest now. Let these thoughts settle gently into your mind like snow falling on quiet ground. You've journeyed through time's mysteries, from relativity's warping to quantum uncertainty, from the Big Bang to heat death, from the smallest Planck moment to the vastest cosmic eras. You've confronted your own mortality and found perhaps not answers but perspective. You exist in time. You are made of time. You are a pattern that time allows to temporarily persist before dissolving back into simpler forms. That's not tragic, it's the nature of existence, the price of complexity, the cost of consciousness. And the gift is this: you get to be here now, aware, wondering, alive in time. You get to witness the universe's astonishing beauty, its elegant laws, its deep mysteries. You get to ask questions that echo through millennia of human wondering. What is time? What am I? Why does anything exist? You won't answer all these questions. No one will, but the asking matters. The wondering matters. The willingness to confront mystery with curiosity rather than fear, that matters deeply. Time will continue flowing, or seeming to flow, or being traversed by your consciousness, or however it actually works. Moments will arrive and pass. You'll age, change, eventually end. But before that ending, there are so many moments still to come, so many chances to love and learn and grow and simply be. Use them well. Spend your time on what truly matters to you. Connect deeply with the people you love. Pay attention to the astonishing world around you. Find wonder where you can. Create beauty if possible. Reduce suffering when able. Live authentically. Choose consciously. Love bravely. And when you can't do any of that, when you're tired, confused, struggling, be gentle with yourself. You're a temporary pattern in an incomprehensibly vast universe, doing your best to navigate existence with limited understanding and limited time. That's enough. That's more than enough. That's everything. Thank you for spending this time with me, for wandering through these questions together, for bringing your consciousness to meet these ideas. Your attention is a gift. You could have spent these moments anywhere, doing anything, thinking about anything. You chose to spend them on wonder. That choice honors time. It honors existence. It honors the magnificent, mysterious, fleeting opportunity of being alive in a universe strange enough to contain both you and time itself. Sleep well, dear friend. Rest in the knowledge that you are exactly where you need to be in time, right here, right now, alive and aware in this present moment. Everything that has ever happened led to this now. Everything that will happen flows from it. You are time's child and time's witness. Brief as starlight, precious as dawn. Good night.